is there a way to invent primes, to generate primes, and never, ever, ever come up with a problem? And the answer is, yes, there is, so long as you know what this number is. Okay. These are called Mills primes. Okay. So Mills was a mathematician, and he said, look, there's a special number. Actually, there should be more than one special number, but this is the smallest one that's known. Okay. Such that if you do a particular thing to it, you will always get, every single time, not like Mersenne, right? Every time you'll get a prime. Now, I'll show you the formula, but things need to be explained about it. Okay, so this is what the formula looks like. Yeah, I know it looks weird. I'll explain it. Okay, so what's this? First, okay, you've got these weird boxes out here, and it looks a bit like a matrix, but I left off the tops, which is important. Okay, this is called the floor function. Yep, that's the actual name. The floor function. What it tells you is it rounds down whatever you give it to the nearest integer below. Okay? So we're familiar with the fact that, 3.1 rounds down, 3.2 rounds down, etc., etc., 3.5 rounds up. The floor function rounds down no matter what the decimal is. So 3.5, floor function would equal 3. 3.9. Don't care, floor function equals 3. Another way of thinking about it is it subtracts the non-integer part, whatever that might be. Always subtract. There is, by the way, an opposite function to this. It's not called the floor function. What do you think it's called?
Roof function.
Come on, we're inside, people. It's the ceiling function. It's the ceiling function. And it does the opposite. It does the opposite. Look, 3.1, we would usually round that down, but the ceiling function would make it round to 4. Okay, so anyway. The ceiling function happens to not be very useful in this particular context. So what's this? The floor function of this number. What's this number? This is the Greek letter mu, right? And it's M for Mills, right? So rather than using M, which usually means mass in maths, but anyway. Okay. So mu is a Mills number. This is the smallest one that's known. Mills theorized that there were more such numbers. Okay. If you raise mu, okay, to the power of 3 to the power of n, where n's any number you like, right? You'll always get a prime number every single time. Okay? Now keep in mind, this is the number. Okay, so what I would advise you do is get your calculator out, manually punch this number in, okay, and then store it in your, so you don't have to type it out again. Okay, store it as a letter. Right? Like say store and then pick A, B, C, D, whatever you like. You can pick M if you like. Okay? So if you cannot remember how to do that, here's the way you're going to do it.
I don't have the same calculator.
Okay? So what you want to do is, first step, just type the number. First step is type the number. So 1.306. Okay? Now once you've got that number there, press equals. That number will go on the bottom display, not just your working. And then what you want is shift, this button which says RCL for recall, just above it, in yellow, it says STO for store. So you go shift, store, and then pick one of the, on my calculator, the letters are all in like magenta, pink, dark pink sort of color. And pick a letter, okay? And then it'll tell you, yeah, all right, that answer is now in whichever letter you've chosen. Okay, got it? So that's just for convenience, just so you can manipulate it. All right, now, what are the numbers? What are the primes that get generated by this thing? Well, you're going to take this number and you're going to raise it to the power of 3 to the power of some number. So if I say n equals 1, I'm going to raise mu to the power of 3 to the power of 1. So that's mu cubed. Okay, mu cubed, does that make sense? Okay. Yeah. So you go through, and I've got it on A, right? So you go alpha, the button with A, and then you cube it. So what do you get? Well, before I round it, I go 2.22949, right? But of course I want the floor function of that, right? The floor function, so you go floor, so that of course is equal to 2, which is prime. Cool. All right, hold on. Neat party trick, but that's just one number. Okay, let's do the next one, right? So you go mu to the power of. Now if I say n equals 2, right? then this will be mu to the power of 3 squared, which of course is 9. Okay? So you punch it in, right? You go mu to the power of 11. 9, beg your pardon. And then the number that you get is 11.082, etc. But of course you want the floor, which is 11, which is prime.
But sir, that means that according to the mu function, 1 is a prime number.
Well, okay. So for natural
3 to the power of
numbers,
0.
this guy.
3 to the power of 0 is 1.
Okay, so positive, like no, actually, sorry. Yeah, so not non-zero, not counting 0. Is that okay? So I started from n equals 1.
And does it give you all of them?
Well, we went from 2 to 11. So I've skipped 3, 5, and 7. But then again, every prime generator will skip some numbers. So you're just, and to be honest, I don't mind all that much for my intents because remember, for cryptography, I don't care about these small prime numbers anyway. They're no use. I want big ones, okay? They're the ones that are really valuable for encryption, okay? Now, just because our calculators can handle it, what's the next Mills prime? It would be mu to the power of 27. Now can you see, by the way, why I gave you this ridiculous number of decimal places, right? I'm raising it to the 27th power. These numbers down here are small right now, but you multiply them by themselves 27 times, and it'll matter, okay? I think my calculator, at least, it can go up to the next one, which is 81, I think. So it'll do mu to the power of 81.
But sir, where does mu come from? Is it a fraction?
Well, no, it's not. I get 25210088887.